So there's another aspect of the building structure that we need to think about when we're coming up with the loading that the code requires, and that's going to be the period of vibration of the building. So let's take a look at how we're going to deal with that aspect. So we're trying to determine what's the period of vibration that this building would vibrate in its natural frequency. We talked a little bit about this under structural dynamics, but mostly now we're working on this calculation of the design loads. We're working on this first step on defining the characteristics of our project. So various characteristics. Now we're ready for this fifth one, the period of vibration. So keep in mind, this is the amount of time required for the structure to complete one cycle of free vibration. If somehow we pulled the building to its side, we let it go, sways all the way over one way, comes all the way back, that amount of time is the period of vibration. We give it the symbol of capital T, and the units are in seconds. We actually have a couple of different methods we are going to use to try to estimate what that period of vibration would be. Keep in mind, we're talking about a large structure made of multiple individual components. We're trying to grossly estimate how that might vibrate. Method A is an approximation provided by the building code. Method B is going to be coming out the output of a dynamic analysis on the computer. So for method A, we're going to use this kind of basic equation from the ASCE 7 document. H is going to be the height of the roof, either in feet or in meters. The C sub T and the value of X we're going to get from this short table that comes from the building code. One of the things I try to mention to engineers is keep in mind that, usually I'm filling out a form or something and it's asking me, let's say, ethnicity. And so there are various choices. And then there's usually one for other, which is the handful of people that don't fall in any of the major categories. Building codes are oftentimes and so what I mean by that is other is usually not the option that most people pick. Building codes are a little the opposite. Oftentimes, this category of other at the bottom of the table is the one that contains the vast majority of structures. So don't be hesitant to use those values when you don't meet the requirements of something else. There's a moment resisting frame of steel or concrete. There's a couple of different braced frame configurations, and then everything else in the world falls in this other category. So these are really only a handful of projects that fall in these top four rows. The vast majority of items are going to fall into that all other structural systems category. If you do work, these are all values for height of the building in feet. The code actually provides you a different set of values if you are using metric, and then you're going to use the height in meters. So that's method A. Very quick little calculation gives us actually a rather accurate estimate of what the period of vibration will be. But method B is the process of going through developing a structural model in some kind of computer software and running a dynamic analysis, a modal decomposition, and having the analysis tell us that based on the mass and the stiffness of various portions of the structure, the period of vibration will be a certain amount. Keep in mind this modal decomposition gives us modes in two perpendicular directions. So we're actually interested in the lowest mode or the largest period in each of the two directions, X or Y. Method A gives us the same period of vibration as long as we're using a moment resisting frame in both directions of the building. We get the same value for this period using method A. Method B actually may result in different periods of vibration in the X and the Y direction. Most engineers expect that this method B gives a more accurate estimate. I mean, it really does take into account the size of various members, the locations, the distribution of mass. It turns out that oftentimes the period will be longer than the value that you calculate using method A. And as a heads up, something we'll see in the later lectures, the longer the period of analysis vibration for a structure, that actually results in lower design forces that we need to use. So it's preferable to us as an engineer to have to resist lower forces. So it's preferable to have calculate a higher period of vibration. It is possible to get two different periods in two different directions, but it does take time and money to develop a sophisticated structural analysis model, and some projects it just isn't justified if that's the only thing you're using the structural analysis to calculate. Now, there's a little concern that engineers might get a little carried away with how they work on their model, and while they're trying to get the period to be as high as they can, they might be a little too aggressive, and maybe the method B starts giving periods of vibration which are very high. Well, there's a requirement in the code that you can use the period of vibration for method B, but you can't use a value larger than given by this equation T max. C sub U, T sub A is what you calculate using method A. C sub U has various values. It's usually 1.4, but the code does have 3 or 4 situations where the value may be lower than 1.4. So I calculate the period of vibration using method A. I calculate, I might choose to set up a structural analysis model and calculate the value using method B. When I look for determining the period of vibration for my structural equations, I'm going to either use the maximum value in this equation or method B, whichever those two is smaller. So the IBC code gives me two different methods of predicting the period of vibration. Method A we always use. It's probably the only thing you're gonna use when you're taking an exam, because you're not gonna have a software program. Method B is used for larger structures. As software becomes cheaper and engineers become more comfortable with it, we're seeing smaller and smaller projects being analyzed this way. But it does require the time to do the modeling, but it may lead to a reduced cost in the overall structure if the loads are going to be smaller. Thank you.